we are done looking at our measures of central tendency, let's take a look at ogives. Rules regarding ogives. 1. An ogive must always be flat or increasing and can never decrease. This is because an ogive is going to be depicting the cumulative frequency of your data. That it means that the highest value of your ogive is going to be the total number of data points that is going to be reached by the ogive. So each point on this ogive is going to be plotted at the end of a class interval, and the ogive will start in the lower bound of our first class interval. So let's say I've been given this set of data, and I want to draw an ogive relative to this set of data. This is what my plotted points will look like. So if we're looking here at 6, we notice that that is going to be the upper bound of this class interval. If we're looking between the points 6 and 9, you'll notice that I've plotted my final point at 9, where we have our frequency of 40. The same between 9 and 12, we know that our frequency between this class interval is going to reach up to 75. Between 12 and 15, the cumulative frequency lay at 95. And between 15 and 18, the cumulative frequency was 100. Let's use our ogives. Let's see how we can use our ogives practically. We've been asked to approximate a 5-number summary for this data. So our 5-number summary, if we remember, is going to be the minimum, the lower quartile, the median, the upper quartile, and our maximum value in this data set. The minimum value in this data set, if we read it off of our ogive, is going to be at 3. The maximum value in this data set, if we read it off of our ogive, is going to be at 18. Let's look at our quartiles. Now, our lower quartile, right, is going to be, actually let's first take a look at our median. Our median is going to be positioned halfway through this data set. So if we have a net number of 100 data points, halfway through that data set is going to be at 50 points. Therefore, reading this off of our ogive, we're going to have an approximate value between 9 and 12. Let's just say that's going to be 10. If we're looking for our lower quartile, remember our lower quartile is going to be midway between our lowest bound, our minimum value, and our median. And so halfway between 0 and 50, in this case, is going to be at 25. So we're going to read off of 25 on this ogive, and we note that that's going to be between 6 and 9. We're just going to say, estimate that that's going to be equal to 7. And our upper quartile, Q3, is going to be in the topmost 75%, that is between our midpoint and our topmost value, between 50 and 100, that is going to be at 75 approximately. Therefore, that will lie at about 12. This is our approximation of our 5-number summary using our ogive. Now let's state the modal class if each class interval is 3 units wide. Now remember, the modal class is the class in which we have the highest frequency of our data. And so in this ogive, that's going to be the class in which we have the steepest gradient on this ogive. Looking at this ogive, we can see that it's going to lie between these 2 points, and that is going to be between 9 and 12. Therefore, the modal class is going to be between 9 and 12. Now we've been asked to approximate the number of runners who ran less than 8 kilometers per hour. So we're going to read off of our x-axis where approximately 8 kilometers an hour would be, and find the corresponding y value. And that's going to be somewhere between 20 and 30 at about 22. So approximately 22 runners ran at less than 8 kilometers per hour. Now they've asked us to draw a histogram for the data on the same set of axes as the ogive. Now, your histogram is going to be depicting the change in our cumulative, in our frequencies of this data set. So, practically speaking, if we're looking for our bar in our first class interval between 3 and 6, we have gone from a data point of 0 to 10. So that bar will rise up to 10 units on our y-axis. In the next class interval, we have moved from 10 runners to 30 runners. Therefore, we have increased by a factor of 20. Therefore, at 20 runners is where our bar will rise. In this third interval, between 9 and 12, we have gone from a value of 30 runners to 70 runners, which means that we have changed by a factor of 40. Therefore, at 40 is where we will draw our bar. In this second to last interval, we have increased from 70 to 90, which means we've changed by a factor of 20. So at 20 is where I'm going to draw my bar. And in our final class interval, between 15 and 18, we've changed by a factor of 10 between 90 and 100. Therefore, I will draw my bar up to 10 units. And that is how we will depict our data on a histogram by interpreting our ogive. The next question asks us to state the total number of data points, and that is pretty simple. We just look at the end of our ogive. We note that that is at 100. Therefore, the total number of data points is equal to 100 data points. And finally, they've asked us to give the value of the 90th percentile. Now, the 90th percentile is going to be the range of data in which 90% of all of our data points fall. So, out of 100 points, the 90th percentile will be the first 90 points. Therefore, at 90, you will be able to discern that everything that falls below this line will fall within our 90th percentile. And that also means that everything that falls above this line will account for 10% of our data. In this instance, our 90th percentile will be approximately between 15 and 18 because it lies at the point 90. Therefore, we will approximate that the 90th percentile is going to be at 15. Can I redo that slide? Because I think I've drawn very skew lines.
Yeah, sure.
Sorry,
okay.
just one sec, yeah.
Top of slide, 3, 2, 1.
Finally, let us calculate the value of the 90th percentile. Now, the 90th percentile is just going to be that range of data under which 90% of our data points will fall. In this case, 90% of 100 data points is going to lie at 90 runners. So if we're drawing our line from 90 runners, we'll note that it lies just below 15, so around about 14 and a half runners. 14 and a half will be the range in which our 90th percentile lies. And interestingly enough, where we have found our 90th percentile, it also means that above that percentile lies 10% of our data. Okay, and that is the end of part 1 of our stats workshop. Thank you so much for joining us. Good luck with your studies, and I hope that this was really educational for you.